This is the NTP lab. We're going to configure network time protocol in this network. We're going to use router 1 as a stratum 1 and router 2 and router 3 as a stratum number 2 for this network. And we will use loopback addresses in order to identify the NTP servers, because given we have a redundancy here with OSPF, using interface IP addresses is not recommended. So let's go to configure it. And, it is actually quite easy to configure. Notice that when you issue show clock in a network that has not NTP configured, your show clock will show you a dot. That means that you're not synchronizing with anything but yourself. And it can also show a star, and that means that NTP is configured but still not synchronized. And when it shows you nothing, that means that it is synchronized with NTP. So let's configure this router as NTP master, having a status of 1. Let's also notice that the clock is showing up as universal time, and you have to configure it to your time zone. So first of all, you have to enter the command clock time zone. For instance, for me, Central Standard Time, that is 6 hours behind the universal time zone. And if you're using daylight savings time, you really should use this clock summertime and enter your summertime variation that applies to your country. This is important because if you don't use these, when you are in summertime, you will have a variation of 1 hour. So you don't want to have that. The objective of the network time protocol is to synchronize the correct time. So you have to configure your daylight savings time correctly. So I'll have to enter this command in all my routers and devices. And this is where automation comes handy, because you have to enter it in all your devices. Notice that if you don't do that, your clock will be UTC. Oops. The next thing will be to synchronize clocks with network time protocol. We already entered this as master, and we're going to configure router 1 as the stratum 1 server for this router. So NTP server will be this. This is the loopback address that belongs to router 1. We're going to use that in router 3 as well. For these devices, these switches, they will have 2 servers. NTP server, which will be router 2. That will be the, I will prefer this. And router 3 will be another server. And here I will choose the same. And router 3 as a backup. And here I will choose this one as the preferred server in order to load balance the network time protocol requests. Okay, now we can issue show clock. Notice that now there is no character at the beginning. That means that this is synchronized because it is the root. Stratum 1 reference is local. Associations itself, you want to have association that have this asterisk at the beginning. You want that. Show NTP status. It is synchronized. It is a stratum 2. The reference is router 1. Notice the dispersion is a bit high. We're going to have high dispersion here because it is a simulated lab. In real life, this dispersion should start to diminish as time goes by. Show NTP status. Synchronize. Show clock. There is no character here. And these are devices that are further away from the servers. This is unsynchronized. It is a stratum 3. It has a reference, but it is still unsynchronized. The root dispersion is high. And we can see, show NTP status. Show NTP associations. We have one with asterisk, and the show clock is showing a dot. This means that it is unsynchronized. This is odd. This is odd, and not behavior. It probably be it should be an asterisk. Show NTP status. Probably if we ping the reference, we can make this simulation to wake up a little, and the root dispersion is lower now. Well, that's it.